So we are talking about API facade pattern composition.
What's cool about composition? What are we going to delight people with?
I think it's a known thing, composition, but in the context of mobile and the applications, apps, there are insights to be shared and still coming up. So thought it's going to be valuable to share that.
Hello, welcome to Essential API Facade Patterns, Episode 1, Composition. Thanks for joining us today. In terms of prefatory material, remember that you can check out a fantastic community of API thinkers and doers on a Google group called API Craft. The best way to get there is just Google API Craft. The slides that we will present today and in the rest of the series, and all the slides that we presented in the past, are available on SlideShare. If you go to slideshare.net/apogee. This video and the other videos in this series, after we take a couple days to edit them down, they'll be available on YouTube at youtube.com/apogee. I am Brian Malloy, and I'm joined with a very special guest today.
Hi, I'm Shantanu. Thanks, Brian. I basically come from an integration background, have been doing lots of SOA, file types of integration, and of late, API integration.
Fantastic.
Let's do it.
And I want to say we collaborated on this content, but you really did all the content.
Yeah, that's the smallest of you.
But I'm really excited about this stuff. It's always awesome to talk about API, design patterns, and architectural thinking. It's really, in my opinion, intellectually stimulating. And this is the first of a 4-part series. Today we're going to talk about composition. The follow-on episodes will include session management, 1-phase to 2-phase conversion, and synchronous to asynchronous. If you are on this mailing, we will send you the slides and the video for today. We will also send you a follow-up email for the next series. The next episodes in this series. So let's go ahead and get started. So we're going to lay this out into 4 simple components. What's the problem? What's the solution? What are the benefits? And what considerations should we take into account? So let's go for it.
Yeah, that's right. That's how it is structured. By the way, let me just point out a fact that API patterns are not so much different if you consider standard integration type of patterns, which are there for ages now, right?
Mm-hmm.
So while blending my way into the API world, what I figured out that what we need to do is put those same insights with a slightly different perspective,
Okay.
and that is where things getting interesting, right? So let me talk about the problem, right? That's the first part of the presentation. So the problem here in terms of composition is very simple. It's about mashups, right? In most of the apps, we see a lot of mashup content coming in. To give you a couple of examples, let's talk about this Flipboard, for example.
Okay.
Everybody
Flipboard, you're talking about the iPad app?
Yeah, let's talk about iPad or iPhone,
Okay.
right? It syndicates content from multiple sources. It might ask your Facebook password. It might take your other content password, and then it gets it for you and displays it one place.
Okay.
That's one example. Let's take another example of voice-based search, which is there in Android phones, which is there in iPhones. What it does essentially, it takes your speech, makes an API call to talk to the voice to text engine, gets the text back, and then issues the search, which is the next call. So these are the kind of mashup scenarios, right? Some of them are pretty cool, like mashing up multiple data, like Flickr does in Maps, right? So that you can see the location of your pictures.
Yep.
Right. So here, essentially on this slide, what we see that the client device, which runs an app, is trying to get content and data and application from multiple services. Service 1, Service 2, and Service 3, and so on, right? So what is the problem of doing this? Basically, it has to make multiple connections, it has to mediate security with these data sources, and of course it has to normalize the data and so on.
Yep.
That's the job of the developer who is developing the application. They always do it. Now, if I go a little bit deeper into the problem, right? What we see is, because it's mobile device, the resources are really, really scarce, right? Like your network connection, your data, your battery. If you go to an app store, let's say Android App Store or even iPhone App Store, what you'll start finding out, there are apps which actually figures out which other apps are eating your battery, which other apps are taking a lot of your network bandwidth, which keeps on pinging the server. Right. So basically, that's a very sensitive thing, and you might get just people might just uninstall your app if it is taking a lot of these resources.
Yes.
It's difficult to hide it inside the code. Right.
Mm-hmm.
And then doing OAuth with multiple servers. Let me put it this way. Right. Maybe Twitter does OAuth 1, maybe Facebook does OAuth 2, and so on. So
yes.
it's a bit of a more programming overhead that you have to do. I'm not even getting into the point of merging data and manipulating the formats and so on.
Sure.
Right. So there is a lot of work to do. So now let's talk about the solution part of it a bit. Right.
Cool. How do we solve this?
Yeah, the solution is as I look at it, it's pretty simple. Just bring in a facade layer. Basically, conceptually the same thing. However, this layer, the API service layer, the way I call it, you can call it a facade, you can call it a, just a services layer, whichever way you want to call it. Essentially, it has to provide you very basic services like a facade does, right? So
what kind of stuff is in the service layer?
Yeah. So when it comes to implementation, the technical implementation might actually have a composite number of components in it, like an API gateway. It could be an app server. It could be a handwritten servlet. It's essentially a server-side component. It might have persistence in it, right? And it may be a combination of few of those.
Got it.
Right.
Sort of like a Swiss Army knife for dealing with HTTP. Stuff. Cool.
And of late, most of the app developers are having a server-side component of their own to do this kind of things.
Sure.
Right. So, okay. So what do we do with this API service layer in between? And what are the benefits, once you have put this in? What we can clearly see, it essentially, stops all these multiple connections, more data connectivity and all these things, and puts into one single layer. I think it will be more clear if I start talking about one example.
Sure.
We're talking about, making multiple calls, but, let's take a use case. Okay. This next slide is about this use case. Let's imagine there is a cab booking application on a user's, mobile phone. What does this cab booking application does? It essentially tries to book a cab based on your present location. That will be your pickup location. And it will also save your booking history so that later on it can be used for billing or it can be used for more bookings, right? Sounds simple. Now, in order to do this, what the app has to do is get the location based on your phone number, or your network location. So there are operator network APIs that provide you that kind of service today. For example, if you are Verizon or if you are AT&T, you can go and get your location from your operator's network. Once you get the location, you want to find out a cab service which takes booking based on these location coordinates, right? And then once the booking has been done with the cab service, you want to persist that booking in a user profile management storage service, right? So this is the sequence. Here in this case, we are making one call after the other, right? And essentially we are trying to park all this responsibility onto the services, API services layer. That makes the developer's life simple. I'll explain why I say so, right? Essentially, if you look at the speed of change with which the applications can change on the mobile versus the speed of change with which the backend APIs might change, and versus the change that you can bring in into this API services layer. The speed at which you can change the API services layer, I assume it is going to be much more, because if you have to certify an app and then publish a new version, and you have to continue to support multiple versions of the APIs and so on, right? Okay.
So the benefits.
Yep.
What are they?
I think we covered some of them, but let's go into the nitty-gritties of the benefits. So here, as you can see in the diagram, the application authenticates. It can be a simple authentication. It doesn't need to do, let's say, auth. It can just do a simple authentication with the server-side component of the developer, and the server-side component of the developer can persist the earlier obtained whatever tokens had been done with the third parties.
I know every time we prototype an app, that's what we do. We get the token and we persist it in that service layer because that way we don't need to worry about doing the OAuth dance every time you fire up the app or whatever.
Absolutely.
It's just a lot smarter. Cool. All right.
So that's one big advantage. So you don't do all the dance all the time.
Yeah.
Right. And if you look at the next one, it's basically going to make less number of network calls from the device.
Yeah.
So that will essentially mean less data usage, less number of connections, and your app will become really cool and a little bit more calm when you are trying to detect those kind of activities, right?
Mm-hmm.
Which is good. And going to the next one, right? This is a little bit practical problem. So what happens is your service providers all the time can change, or you may want to tie up with a different service provider.
Sure. So in this case, you might be using Yahoo's geocoder. You want to switch to Google's geocoder. Without this service layer in the middle, you're updating every single app that's on every device out there in the wild in production.
Absolutely.
Okay.
So that's a big headache. You don't want to impact all your users.
Right.
Even if you want to, they take it's an optional upgrade for them. They take a while before you switch over all of them.
Right.
But if you have this facade in between, you kind of absorb that change. You manage the version on the API services layer, and you can continue to support a single version of your app, which is much cleaner, right?
Right.
Okay. So let's go to the next one. So here, this API services layer in the middle, it provides a single point of control. For example, if you have to worry about error codes, if you have to worry about compensating some of it, if you have to worry about not going forward with some of these calls because the request wasn't qualified. So this kind of additional logic, you can do a lot of this programming. Like I said, the quantum of change that you can implement in this middle layer with traditional server-side languages and skill set is much more easy to do. And the process of changing, the workflow of changing is simpler compared to that you have to follow on the other side, the provider side where you have no control, and on the consumer side where you may have a very little control again.
Mm-hmm.
Right? Request payload manipulation. I think this is a no-brainer. Of course, you can, once you can manipulate the request for the respective services. Also, you can merge them back. Like for example, some of your backend can be SOAP. You may want to do XML. You may want to make it JSON for your client to consume and so on. Right? To me, I look at it this way. The developer is not only doing the app anymore, they're also taking a big part in the server-side component so that they can consume the services they really want to.
Yes, right.
Right? So it makes more sense to basically, put more code in the API services layer and not rely completely on the developer side of the story.
Yep. Two examples there. One is Twitter just announced that they're deprecating XML support for their API. So if you had either an XML library that you really liked or you had something deployed out there in the wild and you absolutely needed to still support XML, even though you're only ever going to get JSON from Twitter, you could do that payload manipulation here and just say, hey, whatever request that comes in, if you ask for XML, we're going to manipulate it in a way that we give you XML off the JSON. The other one is cross-origin resource problems, where we run into this a bunch as we build apps that you want to use an API, but you're using just a thin JavaScript and HTML5 client. You can't do the cross-origin thing unless either the person is giving you the right response or you've done something like run it through this API service layer.
Yeah, absolutely, that's a very good, valid point. Great point, actually.
Yeah.
Right.
Cool. All right, next one.
Yeah. So the next one is again, it's a favorite one of mine. Right. I talked about specifically storing the user profile information like the history of bookings, right? Now there are a lot of backend as a service opportunities there which developers can use it. So in order for the developer to use such service without really burdening the user side, right, or without really making it very transparent as to these are the number of calls going out, this is one profile that are going out, right?
Yeah.
It may be anonymized, it may be right? It may be just collected as an analytics and still saved into the back end of the service storage. It is more like a storage. It can be contextualized to have user preferences and history and so on. You want to add something on that?
Yeah, well, this is one that when I first saw it, I didn't understand the value of it. And that's because when I first saw the idea, okay, so you want to throw some extra arbitrary user profile information, my response is just build a really quick Ruby on Rails app in front of Postgres and deploy it out on Heroku, and then you've got your general purpose data store in the cloud. But the thing is, and this is what separates me as a web generation developer from the current generation of app developers, if you're getting everything else that you need through publicly available APIs,
yep.
The idea of understanding how a relational database management system works and an app server and all that stuff, it's really not worth the effort, right? You're
Absolutely.
much better off using something like Apogee's app services or Parse or one of these back-end as a service providers.
Well, one can argue as to if I'm using an API service layer in the middle, I can as well pump in a database there, right? And store everything that I need there. The argument that I will propose in kind of to counter argue against that is, again, you don't want to tie yourself too much down into one layer. For all you know, this API service layer facade that you're going to use for smaller developers, right? It may not be your own service. It may be some third-party hosted, a cloud-based service.
Right.
So you don't want to tie yourself down into one, right?
Absolutely, that's a great point.
Right. So okay, the next one is about collecting analytics.
Yes.
Some of this services layer does it by default. So for example, some gateways will do it, collect the user data, and it will collect the usage data, error data, latency, availability, and so on, operational data as well. And what I have observed is collecting analytics on the device is still hard. There are bits and pieces of innovation coming in there. Some SDKs do it, some native libraries do it, and then again send the data back into a analytics server. But unlike the web world, where all the analytics are captured from the web browser, back in the days when you used to have web trends or hitbox kind of solutions, they used to collect your data from the browser by JavaScript and push it into a server, right? Here, trying to do that from a device, again, it will have all these complexities of making connections, and it will become transparent and visible to the users, right? That you are making connections and so on. So here it makes sense to collect the analytics data in the middle,
Sure.
right? And that's another great value add that this particular pattern provides you, right? Okay. So with this, I think we have come to the logical conclusion of the solution as well as the problem statement. We can talk about a few more considerations going forward, right?
Sure. Well, I don't know if we'll get into it in this next section. To put you on the spot here a little bit, the benefits are really, really strong. But what are the reasons people should consider in terms of trade-offs? There's nothing for free. So what are the downsides? What's the other side of the coin here? Why might you think twice about using this facade system in the middle?
Yeah. So basically, when you start off with a plan of developing a new application, right, you don't always see that I'm going to end up talking to, or I'm going to end up enhancing this to be more feature rich, and slowly it will become, it will start talking to 5 other services. So you don't bother to put the, API services layer in the middle. You start it with vanilla, right?
Right.
But if you think about long-term vision, a lot of times these apps that come up, right, you never know until they really become successful or until they really pick up. It might be just another effort. So that is one counter argument that, well, I don't really know where is it going to go, so I can't really spend all the time.
Sure.
Yeah, it's
you would be over-engineering the solution.
Exactly. It's like speed of adoption versus how much do I want to engineer.
Right.
That kind of thing.
Right.
And
Now, here's I'll throw one at you. When you said single point of control, I bet a lot of other folks were thinking single point of failure.
okay, so that's why I said the implementation of the API services layer, though it is coming out as a single logical component on the diagram, essentially I would expect this layer to be a really, really cloud-hosted, fault-tolerant, multi-region kind of system,
Right.
which can kind of serve to your customers all over the globe. if needed, do geo-DNS kind of solution and all that, right?
Right.
Some of it should come kind of, packaged to the developers.
Right.
I don't believe all the developers should do it by themselves.
Okay. So speaking of developers, Brent in the chat window here from BC says slightly more development time, which on the surface it sort of seems like that would be true, right? Because you're introducing one more piece, one more component. Is this the kind of thing where, hey, yeah, there's a little bit more development time up front, but it's going to pay you back later on? How do you think about
I agree with this point. I would say yes and no, because if you are looking at your development number of lines of code or number of class and modules you are going to develop, if you do it on a server-side component, let's say on Java and Python and all that, right, on the server, versus you try to do it on the Android device, your code footprint increases, right? So I think that in order to engineer that part, you spend a lot of effort in optimizing it. So I think that additional effort that Brian is talking about is probably what.
Yeah. Cool. Should we look at some of these other considerations now?
Yeah, if there are any other questions, we can take that and probably move on.
Cool. All right. So the other scenarios are parallel callouts, compensation, and chatty services.
Yeah. So I think this comes as a corollary to the basic pattern, right?
Okay.
If you are trying to make parallel connections, right? A server-side component is much more better poised to spawn out multiple threads and collect data. In the previous example, we had sequential callouts because we wanted to first know your location, then we wanted to know can we make a booking, and then we wanted to persist in the history. However, if you have a situation where you don't really care about the sequence, you want to just grab the data and merge it together. One good example could be, let's say I'm talking about collecting some data about a movie. Now, maybe IMDb is a free service which provides me some information, but the not entire piece of information I'm looking for. I have to call out for the same movie to another source service and just merge it.
Sure.
In this case, I can go parallel. I don't have to do it in sequential manner, right? I get the data from both the source and I merge it in the server. So parallel callout is going to optimize the performance and so on. So that's another opportunity to do it, when you do it on the server side.
Fantastic. All right, next one. Dealing with chatty services. This is pretty common.
Yeah. So when people craft their API, I mean, that is your favorite area, right? You always talk about it. So I think services provide value. That's why they get consumed. But at the end of the day, a lot of times people don't pay enough attention to crafting the service signatures and all that, right? The coarseness and the granularity of data too much, right? So what ends up happening for a practical value-added application for an end user may end up talking to the same host over and again for first doing authentication, then doing get me the context, then do some more things, and then finally I get the data, right? In this example I have given, right, get the user's attributes and then get the user's preferences and then get some recommendations about the users.
And often this happens with associations just like that, where you get one element and then it has 6 elements associated with it, so you can get another request to get the associations.
And one reason they have designed the services probably because they wanted to make it more modular and the payload small and all that, less complex. Now, this kind of chattiness, again, it will increase complexity on the application. So we would, again, bring in a layer in between and reduce the complexity of chattiness, right? Is again, sounds very similar to the composition.
Cool. Fantastic. Solution is to reduce chattiness.
Yep. It sounds very simple.
Right.
It may not be that simple because if it's authentication, other things involved, maybe a little bit more. But yeah, but principally it should work like that. Right.
Very cool. There's some discussion in the chat here about transactions. The question started with Praveen, and he asks, have you come across the scenarios for transaction management and rollback for the APIs? It might be one-off, but the Facade layer should be careful to not waste resources. Have you seen that? What people are doing, like two-phase commit or multi-phase commit things?
It's a great question. Actually, one of our episodes are dedicated to doing one phase to two phase and thinking about the transactional nature and all that. So I think what the
so you just did a commercial for the future episode. That's fine. Good.
I didn't plan the question though.
Cool. Great. So just to give a little preview to that, though, there'll be some logic essentially that you're going to put in the app service in the API service layer. That's going to help you with that. That's
exactly.
the overall idea.
Exactly, right?
Okay.
So like I said, the single point of control comes in, so it can become the transaction manager for you,
Fantastic.
if you like, right?
Right.
And it can do compensation. It might not want to waste resource. Some of the servers, some of the services are actually paid, so developer has to pay out every time that
Right.
call goes out. So you don't want to make the second call
Yep.
if your first call itself is returned some error.
Right.
Right?
And I think we can both agree with this. This is where did it go? Ken called this out, that generally transaction management is going to be simpler at the API service layer than on the device. That's for all the reasons you mentioned before.
Totally, absolutely.
Great. All right, folks, are there any questions that you had about our content? We're sort of at the end of things here. Okay, so we have one from Gnome asking, what is the best practice for communication between the API service layer and the other services? Well, I'm not sure exactly what Gnome means. Maybe this is the protocol. I think we're assuming is HTTP. And
yeah, I think the best practice is all the time evolving, right?
Right.
I mean, we still see SOAP, we still see JSON payload, and for some of the services we see some standard. For example, in telco world, we have started to see some standards emerge where the API signatures always are REST, HTTP, and they're also agreeing on the signature. They're coming out with things like one API.
Sure.
So, yeah, best practices are emerging in my view.
Yeah, got it. Cool. Any other questions from folks in the chat window? Yep. Thanks for the question, Noam. Fantastic stuff. All right. And our intention today was to keep it short and sweet. We appreciate you. Oh, we got a question from Brent. We are in the process of developing an API and are planning to use an API key for authentication. Any recommendations?
You go at it first.
Yeah, well, our recommendation is always, depending on the context, that to always take a look at OAuth 2 spec first, especially if you're going from direct to indirect model. We have the three-legged requirements there. But if it's simpler than that, then an API key is cool too.
Yeah, if it doesn't require the user context, I would totally agree with using a key.
Yeah, exactly.
If it requires user context, then the complexity of three-legged OAuth comes in. You can't really avoid it. But if you have to do OAuth, like you said, OAuth 2 is much more widely acceptable than the OAuth 1 being hard to do signatures and stuff.
Sure. Now, for this use case in particular, the app services layer in the middle, does that change the thinking about any of that at all? Or is it just more that's just the same?
Well, it changes because you want to become more trusted. If it really doesn't require a user interaction, you would like your partner to trust you because you are if you are becoming a bigger developer over a period of time, you would like just the partners to trust you to say who the end user is.
Yep.
But sometimes you may not be able to negotiate, right? So
Sure.
you still have to do OAuth.
Right on. Fantastic. Thanks, folks, for tuning in, and stay tuned for episodes 2, 3, and 4, where we will go on to tackling some really fantastic issues. And I'll just enumerate those again, including session management, one-phase to two-phase conversion, which is all about transaction management, and finally going from synchronous to asynchronous requests. We'll catch you next time. Thanks for tuning in.
Thank you, guys.